Congratulations, you've made it to the 5th lesson. This part is about naming acids. What is an acid, you ask? Surely you've heard of some acids. We'll find out how to recognize them from their formula. By looking at the formula of a substance, the way you identify an acid is that acids start with hydrogen. That is, in their formula, they begin with hydrogen. Can you think of one important substance that starts with hydrogen and is not an acid? Water would be an example of one that starts with hydrogen and is not an acid. Pretty much anybody else that you see starting with hydrogen, though, you can safely assume to be an acid. When we name acids, we'll cover the easiest rule first. If you have an acid that does not contain oxygen, so nowhere in its formula does it have a capital O, then the name of that acid always follows this pattern. The name will be hydroic acid. You'll notice there's a blank in there. That blank would be filled in based on what the anion is that formed that acid. An anion, remember, is the negatively charged ion that was used to form the acid when hydrogen combined with that negative ion. So in each case, you would look at what ion the hydrogen is combined with, put its root in there, meaning drop any ending, and call it hydroblankic acid. For example, you might have heard of hydrochloric acid before. So this rule is true when you have an acid that does not contain oxygen in its formula. When you have an acid that does contain oxygen in its formula, then you have to look a little bit further. What you look at then is the suffix of the anion. Suffix is a fancy way of saying ending. So you look at the ending part of the word that was the name of the anion. Let me give you an example. On the back of your polyatomic ion, you have a lot of ions that end in ITE. If you're dealing with an anion combined with hydrogen, whose name ended in ITE, then you simply change the ending to make it an OUS acid. For example, chlorite would become chlorous acid. The other common ending we had on the back of the periodic table was ate. If you have an ate ending, the ate ending changes to an ic acid. A common way to help remember this, because you basically have to memorize which one's which, is I ate something icky. What this is telling you right here is that the ate ending would become an ic acid. I ate something icky. If you can remember that, you can figure out how to name acids. Now that we have the rules written down, let's look at some examples. The first example I have here is given to me as a formula. What do you see at the beginning of this formula? See how there's an H here? When I see an H at the beginning of the formula, I take my pen and I write down acid, because anytime it starts with a hydrogen, it's going to be an acid. Then I look at the rest of the molecule. In this case, the rest of the molecule was ClO2. I need to know the name of this ion. Because this is a polyatomic ion, I would find its name on the back of the periodic table. Its name is chlorite. I'm going to write that really small underneath it to help me remember, because I need to know that name in order to figure out what to do with the name of the acid. Notice how this one ended in ITE. When something ends in ITE, look back up on your page, what happens to its ending? An ITE ending changes to an OUS ending. That means I take the rest of the word, the chlor part, keep it the same, but I change the ending. I drop the ITE and make it OUS. I'm writing it in a different color just so it's kind of apparent that the ITE became an OUS. So the full name here is chlorous acid. In the next example, this is again an acid. I know this because it starts with hydrogen. Because it starts with hydrogen, I'm going to write the word acid as the second part of its name. When I look at this formula, what element do you notice is missing? In this formula, there's no oxygen. Because there's no oxygen, look back at your rules. What happens to its name? it becomes a hydro blank ic acid. So this is going to be hydro something ic acid. We need to figure out what goes in the blank. Well, what element do we have here? This element was sulfur, so we would change the ending of it from to ic. This would become hydrosulfuric acid. Sulfur is an element who actually doesn't lose the sound, it actually just gains the ic ending. So hydrosulfuric acid is the complete answer here. In the last example on this page, we have H3PO4. Again, it starts with hydrogen, right? So what can I write down? The word acid. In this formula then, I do see oxygen. So I need to figure out for this PO4 what its name is. When I look on the back of the periodic table, I find that the name for PO4 is phosphate. It's a polyatomic ion. Think about your saying now. The saying is, I ate something icky. Because this ended in ate, it would become an ic acid. For phosphate, you would think you would drop the ate ending. In this case, phosphorus actually gets its back, so it will be phosphoric acid. If you predicted phosphic acid, you're very, very close. It's just with phosphorus and sulfur, they keep their sound here. So the full answer is phosphoric acid. What I want to point out here is that only one of these acids actually started with hydro. That was the one that did not have oxygen. The most common mistake students make is to put the prefix hydro at the beginning of every acid because they see hydrogen here. In fact, when you see the hydrogen at the beginning, all you should be doing is writing acid as your second word. Our last example is going the opposite direction. On the previous slide, we were given a formula and we wrote a name. Now we're given the name and asked to write the formula. Let's start out. Because I see the word acid here, what does that tell me about the formula? Well, because it's an acid, I know that it's going to start with hydrogen, so I'll put an H. I'm also going to look on the periodic table where I see that hydrogen has just one valence electron. That means the charge that it will have is a +1 charge. This is important because I'm going to wind up crisscrossing again. In this formula, I see the prefix hydro. What does hydro mean in an acid's name? It means that there is no oxygen in the final answer in the formula. So in this case, there's not going to be any oxygen. All I have is this root word here, chlor. Because this says chlor, I can figure out that the element it's referring to is chlorine, Cl. When I look on the periodic table, I see that chlorine would have a -1 charge. Now that I know the two ions, I can crisscross here. I get H1Cl1, which of course we don't have to write the ones in, and we would just have HCl for our final answer. Hydrochloric acid is probably the most common acid that you'll deal with in this chemistry class, so that's an important one to know. The next example we have is nitric acid. Again, when I see the word acid, I know that I can write down an H because it means I have a hydrogen to start my formula. My hydrogen has a +1 charge. Then when I look at the rest of the name, I see that this had an ic ending. I have to remember my saying now. The saying here is I ate something icky. What that means is this came from hydrogen being paired with nitrate. So on the back of my periodic table, I need to find the formula for nitrate. Nitrate I find back there as NO3 with a -1 charge. So this is nitric acid because it was nitrate and I ate something icky. What I would do now is crisscross my charges again. I have a +1 and a -1. Those guys would cancel out. Remember that the 3 in the nitrate is part of the polyatomic ion and I'm not allowed to change it, so it stays NO3. Our final example is sulfurous acid. Notice we have acid, so that means there's going to be hydrogen to start it out. Now when I look at this name, I see that it has an OUS ending. An OUS ending, just like I knew the ic came from an 8 ion, an OUS ending came from an ITE. So if you look on the back of your periodic table, you might be looking for sulfurite, but what you'll find is that it's actually just called sulfite. So on the back of your periodic table, you have to find sulfite. It's that sound in sulfur that gets dropped out of the ion name. And when you find the sulfite, you find that it has the formula of SO3 with a -2 charge. This is why it was important that I was keeping track of the charges, is because when I crisscross now, you'll see that I actually need 2 hydrogens in order to balance out the charge from the sulfite ion. So my final answer here is H2SO3, meaning that there were 2 hydrogens for every 1 sulfate.